Bismillah ar-Rahman ar-Rahim. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha. May God be pleased with her online college. Today's topic in year 2 of A-level maths, pure maths, is parametric equations. And we're looking at trying to find out the coordinates of the intersection with axes. Normally, if you've got your equation as a y equals something x, then that's quite easy for you. But this time, we want to try and get the same kind of answer, the coordinates of the intersection with the axes, just a pair of coordinates, but this time starting with parametric equations. The equation today is the same as yesterday, x equals at squared plus t for the first equation. And the second equation is y is equal to a times t cubed plus 8. And you should hopefully remember from the previous lesson that we've worked out a in the first part of this question as minus a half, minus 0.5. So that means I can rewrite this equation as instead of a, I can write minus a half. And in the second equation, instead of a, I can write the same minus a half. No need to expand out the brackets just yet. I can stay in that form. So that's from the part in the previous lesson. We've worked out what the missing constant was. Now in today's lesson, we want to answer the question, what are the coordinates of the point of intersection? And there's 2 points, A and B, which intersect, have an intersection or cross where the curve crosses the y-axis. Okay, so just picture the axes. We've got the x-axis going across and then the y-axis. We don't know what this curve looks like, but just say it looks like this. Then we're looking for where the curve crosses the y-axis. So that's this point here. And what we know about anything on the y-axis is that the x-coordinate is 0. The x-coordinate is 0. So let's use that. We can say that at the points A and B, the x-coordinate is 0. So let's put that into this equation. See if we can use that to help work out something. So let's put 0 in for x. So x can come here and 0 can go in its place. And now let's try and rearrange. We can take the minus half t squared across. So that would be plus half t squared, or just half t squared. And the plus t, there's nothing in front of the plus, so that can just be t. And then rather than cancel and delete, cancel and remove t from both sides, it's better here to take t onto the same side, and I'll show you why in a second. So we're just going to take t onto the other side. That's going to be a minus t, and that's going to equal nothing on this side. And then the reason you want to do that is because now we can factorize t out. So then we'd get half t in the brackets minus 1. And what that means is that we end up with two solutions. If we had cancelled out t, removed t from both sides, we would have ended up with just a linear equation. But here, because we've got still retaining the t squared because of the t times the t, we've ended up with a quadratic, and we've ended up factorizing to get two solutions. So the first solution is that t alone is equal to 0. And the second solution is that the second bracket is equal to 0. So half t minus 1 is equal to 0. If I take the minus 1 across, then that will be half t equals 1. Think about what to do next. Can times by 2, so you end up with t is equal to 2. And the first one was t is equal to 0. So you've got two values of t now. The question was about the coordinates, so we now need to use that t to get the coordinates. So back into the first equation, we can use a value of t equals 0 to try and get the coordinate, the x coordinate. So if I use t equals 0, then my x would be equal to minus a half times 0 squared plus 0, which is of course 0. Let's use that on the y as well. So if t is 0, then what happens to y? Y would be equal to, let's do the brackets first, 0 cubed plus 8 makes 8, and then times that by minus a half, that would be minus 4. So that's one possible point. We've got 0 for the x coordinate, and we've got minus 4 for the y coordinate. The next thing is to try and get the coordinates for the second point. How can we do that? Have a think. You got everything there on the page in front of you. We'll go back to here, and instead of putting in t equals 0, we'll put the other answer we had for t, if you can remember what it was. So in this area here, t equals 0 was the first answer for t equals 2 was the second answer. So let's put that in. If t is equal to 2, then just type into your calculator the calculation for x, minus a half times 2 squared plus 2, and you should end up with 0 again. And that makes sense because that's what we were assuming right at the beginning, that x was going to be equal to 0. And then t equals 2 into the y coordinate. So type into your calculator minus a half bracket 2 cubed plus 8. And you should get y is equal to minus 8. So that's your second solution, that's your second point, 0 and minus 8. Okay, let's just do a quick recap and make sure you understood all the steps there. We're starting with the parametric equations, and we're trying to find where do they intersect with the y-axis. So the first thing is, because it says y-axis, then we notice that everything on the y-axis, the x-coordinate has to be 0. So we start with knowing that x is equal to 0. We use that to substitute into the equation for x. So we put 0 in for the x, and then try to solve it for t. And then that worked out to be two answers. One was t is 0, one was t equals 2. And then one by one, you're substituting into this equation, into the two equations. T is 0 gave x is 0. T is 0 gave y is equal to minus 4. And then we did it all over again with t equals 2. So your first answer was 0 and minus 4. But then we did it all over again with t equals 2. So now with t equals 2, x did still work out to be 0. The y did change though. So when t was equal to 0, the y worked out to be minus 8. And those are the 2 points where the curve crosses the y-axis. The x-coordinate is 0 in both cases, and the y-coordinates are minus 4 and minus 8. Join me more in our next lesson. Assalamu alaikum wa rahmatullah. Peace be with you and the mercy and blessings of God.